Good morning. Today's lesson is on proportions in triangles. Our standard today is GT1. Prove and apply theorems about triangles, including a line parallel to one side of a triangle divides the other two proportionally. Also, our objective for the day, you're going to learn about those proportions in triangles, and you'll be able to set up and solve proportions to find missing dimensions in triangles. Proving a line parallel to a side of a triangle. Take a look at this diagram. If DE is parallel to AB, then angle 1 would be congruent to angle 2 by the corresponding angles postulate. Also, angle 3 is congruent to angle 4 by the same reason. That would mean that triangle CDE is similar to triangle CAB because it satisfies AA similarity. So, since the triangles are similar, that means that CA to CD would be the same as CB to CE. But if you notice, CA would be made up of segments CD plus DA, and CB is made up of CE plus EB. So if I do a little substitution, we get CD plus DA to CD is the same as CE plus EB to CE. Kind of separating those out, CD to CD plus DA to CD. CD to CD, that would be 1. Same with CE to CE. If we subtract the 1, we get what we want, the fact that DA to CD is the same as EB to CA. We call that the side splitter theorem. If a line is parallel to one side of a triangle and intersects the other two sides, it divides those sides proportionally. So BC is parallel to DE, then AB to BD equals AC to CE. Let's look at this in an example. In this case, we actually have to use the entire triangles. So the lines are parallel, which means that the two triangles are similar. So we would have this. 6 to 18, because we need to use this entire third side, equals x to 16. So we're just using similar triangles here. Therefore, 18x equals 96, cross multiplying 18 times x and 6 times 16. And dividing by 18, we get x equals 5.333. Look at our next example. This is truly using the side splitter theorem. 6 is to x as 3 is to 4, because a line parallel to a side of a triangle divides the other two sides proportionally. So 3x equals 24, and thus x equals 8. A final example. In this case, we got to find out what this final side is. So it's 12. How did I get 12? Well, I simply subtracted 20 minus 8. So x is to 6 as 12 is to 8. Cross multiplying gives us 8x equals 72, and thus x equals 9. We talked about midsegments before in triangles, and we talked about them in trapezoids in chapter 6. Well, because of the fact that we're dividing these two triangles, the lines are parallel, we have the similar triangles, which means that AD to DB, a midsegment of a triangle, segment that joins the midpoints of any two sides. Well, since it divides the sides proportionally, they're in half. That means they're parallel, so it has two properties. It's parallel to the third side of the triangle, and it's half the length of the third side. Notice that the two triangles are similar. Therefore, AD to AB, which is half because it's the midpoint, is the same as DE to BC. Let's do an example. AB is the midsegment. It's half the third side. Therefore, 3x minus 1 equals 1/2 of 34. 3x minus 1 would equal 17. 3x would equal 18, and thus x would equal 6. Now, with this, we also get into proportional parts of parallel lines. If 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. Think about it. If these 2 parallel lines came together down here at the bottom, they'd form a triangle. So we're kind of using that. So if AE is parallel to BF, which is parallel to CG, then AB to BC is the same as EF to FG. Along with that, if 3 or more parallel lines cut off congruent segments, because they're in simply a 1-to-1 ratio. So if L is parallel to M, which is parallel to N, and AB is congruent to BC, then DE is congruent to DF. If they cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Let's do a couple of examples. Find the value of x. Well, notice that you have got 3 parallel lines, so it cuts off the transversals proportionally. GH is to HJ as UV is to VW. So 12 is to 18 as 15 is to x. Cross multiplying, 12 times x equals 15 times 15. 12x equals 270, and x equals 22.5. Look at this example. Again, notice you have three or more parallel lines cut by 2 transversals, which means that it cuts them off proportionally. So 8 is to 5 as y plus 2 is to y. So cross multiplying, we take 5 times y plus 2 equals 8 times y. We get 5y plus 10 equals 8y. Solving this equation now, we get subtracting the 5y over gives us 10 equals 3y, and thus 3.33 equals y. And that concludes today's lesson on 7.5, proportions in triangles.